In this lesson, we're going to subtract mixed numbers with renaming. So if we see our first example, 6 and 3/8 minus 2 and 5/8. When we try to subtract 5 from 3, we notice that we can't do that. So just like with whole numbers, we're going to have to borrow. But the difference is, when we borrow with fractions, we're not borrowing from a neighboring place value column, which is 10 times greater than the column that we're currently in. So it's going to work differently, but it's still the same concept. When we borrow from the 6 becomes a 5. We're going to borrow one whole. Now this whole that we're borrowing can be cut into as many pieces as we want it to be. Since the denominator is 8 and the denominator tells us the number of pieces in the whole, we're going to cut the one we just borrowed into 8 pieces. We already had 3 pieces, so we're going to add 8 plus 3, and that gives us 11 pieces. Again, we borrowed one whole from the 6 became a 5. The whole that we borrowed, we cut into 8 pieces, plus the 3 pieces we already had gives us 11. 11 minus 5 is 6, so we have 6/8, and then 5 minus 2 is 3. This fraction is not improper, but it can be reduced because 2 can go into both 6 and 8. So we will reduce this to 3 3/4, which cannot be reduced. In our next example, 10 and 1/3 minus 5 and 5/6. These fractions have different denominators, so the first thing we're going to have to do is find the least common denominator. The least common denominator for 3 and 6 is 6. 3 times 2 is 6. 1 times 2 is 2. The denominator stays the same. The numerator stays the same. So now when we try to subtract, we can't subtract 2 minus 5. So again, we're going to have to borrow. We borrow from the 10 becomes a 9. Now this time, the whole that we borrowed will be cut into 6 pieces. This denominator is 6, and that tells us the number of pieces in the whole. So we'll take the 6 pieces that we just cut the whole that we borrowed into, plus the 2 pieces we already had is going to give us a total of 8. So you notice we're adding the denominator plus the numerator to get the new numerator after we borrow. 8 minus 5 is 3. So 9 minus 5 is 4, and our answer is 4 3/6. Then we have to see if it can be reduced. Since 3 can go into both 3 and 6, we will reduce this to 4 1/2. Try another example. 8 2/5 minus 3 2/3. Again, we have unlike denominators, so the first thing we need to do is find the common denominators. The least common denominator for 3 and 5 is 15. 5 times 3 is 15. 2 times 3 gives us 6. If you want to put what you're multiplying by in there, you're more than welcome to do so. Here, 3 times 5 is 15. 2 times 5 is 10. We can't subtract 6 minus 10, so we're going to have to borrow. So we come here, we borrow from the 8. The 8 becomes a 7. Now the one whole that we borrowed, we're going to cut into 15 pieces because remember the denominator tells us the number of pieces in the whole. So we add the denominator plus the numerator of this fraction. 15 plus 6 gives us 21. Now we can subtract 21 minus 10. That gives us 11/15. 7 minus 3 is 4. This fraction is not improper and it cannot be reduced, so 4 11/15 is our answer. Now in this problem, we subtract 3 minus 1 3/4. The 3 does not have a fraction behind it. It's a whole number. And when we try to subtract 1 3/4 from it, we have nothing to take 3/4 from. There's no fraction here to subtract from. We cannot just bring the 3/4 down. We have to subtract it from something. So it means we're going to have to borrow. We borrow from the 3 becomes a 2. Now, unlike the other problems that we borrowed in, like this one over here, we don't have a fraction with a denominator here to tell us how many pieces to cut it into. But we do have a fraction here with a denominator of 4. So that tells us that we're going to take the one whole we just borrowed from here, cut it into 4 pieces. You have to remember that one whole can equal any number over itself. So that's where we're getting this 4/4 from. That's where that number's coming from. And the reason we chose 4/4 instead of 7/7 or 8/8 or 5/5 is that this denominator's 4. Since this denominator's 4, we wanted to cut the whole that we just borrowed into 4/4 so that it is a common denominator. We have like fractions, and all we have to do is subtract. This answer is not improper, and it cannot be reduced. If I clear that out and we do another one like that, and we have 5 minus 2 6/7. Then subtract and set up my problem vertically. I can't take 6/7 from nothing, so I'm going to borrow from the 5. The 5 becomes a 4. Now this time when I borrow that one whole, I'm going to look to this denominator, and this denominator is 7. So it tells me to cut the whole that I borrowed into 7/7. 7 minus 6 is 1, and 4 minus 2 is 2. 2 1/7 would be our answer.